Good day, friends. Today I shall talk about a purely mathematical subject. I will talk about the Polish spaces. So let me start with defining what is metric, a distance function. Dx cross x2 real line is a metric if dxy greater than or equal to 0. The distance function is non-negative and equality holds only when x equal to y. Dxx equal to 0. Then symmetric dxy equal to dyx, then triangular inequality dxy plus dyz is greater than or equal to dxz whenever xyz are from x. So equipped with this metric, we call xd a metric space or metrizable space. Real line with Euclidean metric is a metric space. So that is what we meant by a distance function or a metric. Now, completeness. XD is complete if every Cauchy sequence has in X has a limit point in X. So, if X is complete considering the limit points, is closed considering the limit points, then X is complete. Say open 0 to 1 is not complete because I can define the sequence 1 by n that are between 0 to 1, but the limit point 0 is out of the open interval. So open interval 0 to 1 with Euclidean metric is not complete. Separable space. Xt with topology T. Topology T means the set of open sets, the class of open sets on X that defines the topology is called separable or second countable if xt has a dense countable subset. So for real line we have rationals which is countable as well as dense. So real line with Euclidean metric with usual topology is separable. So now what we mean by Polish space. A Polish space is a separable, completely metrizable topological space, homeomorphic to complete metric space and has a countable dense set. Polish spaces are so named because they were first extensively studied by Polish topologists and logicians Sierpinski, Kuratowski, Tarski and others. It has a deep root in descriptive set theory. It is very much used in descriptive set theory as the reference frame. There is a well-known theorem known as Cantor-Bredikson theorem. If X is Polish, then any closed subset of X can be written as a disjoint union of a perfect set and a countable set. I forgot the definition of perfect set. I have to look into it. Further, if the Polish space X is uncountable, it can be written as the disjoint union of a perfect set and a countable open set. So that is Cantor-Bredikson theorem. I am not going into the proof or anything in discussion on it. No. Some example of Polish spaces. Closed subset of Polish spaces are Polish. Open subsets of Polish spaces are Polish. Products and disjoint unions of countable families of Polish spaces are Polish. Locally compact spaces that are metrizable and countable at infinity are Polish. Countable intersection of Polish subspaces of a Hausdorff topological space is Polish. The set of irrational numbers with the topology induced by the standard topology of real line is Polish. Now some characterization. There is Urysohn's metrization theorem that talks about the characterization of Polish space. The problem of determining whether a metrizable space is completely metrizable, whether it is complete or not, is quite difficult. So I talked about open 0, 1, which is not complete, but it's a difficult task to decide whether the space is complete or not. There is a Choquet game that characterizes Polish space. A separable metric space is completely metrizable if and only if the second player has a winning strategy in this game. So that comes from the games. A second characterization follows from Alexandrov's theorem. I am not going to state it. It has some G delta subject which I don't know very well. So why am I talking about Polish spaces? I have a plan to go to study analytic sets and to talk about the beauty of the structure of analytic sets A subset of X is called analytic if A is an image of a Pauli space under a continuous transformation. So what is a continuous transformation? A function fx to y is continuous if for any open set U subset of y we have f inverse U subset of x is open. That is the definition of a continuous set. And any analytic set is a continuous image of a Pauli space. I have plans to study analytic sets. For some reference, I have seen the Wikipedia page on Pauli spaces, and I have this book by Kechtich, Classical Descriptive Theory, which has 3 or 4 chapters on analytic sets. Let me see if it happens, if I can study the analytic sets. I'll stop here. Thank you.